Morning. This is the relearning for defining speed in terms of distance and time. This would be whether all the reading of the graphs. Make sure you write this down on your worksheet. First of all, make sure you put your name on your relearning if I have not done so already, and write down as well what period you have learning lab. That'll help me get you your reassessment. So speed is how much distance an object moves in a certain amount of time. We also say it's how fast something moves. So making sure that we understand this, if I drive 40 miles an hour, then that's faster or a higher speed than if I drive 25 miles in an hour. And so we're going to spend most of our time looking at distance and time graphs because that's where people are running into trouble. So I'm going to flip to my camera here, my dot cam. Again, if you have not already written down which learning lab you have, please write that down. We also want to make sure we have the speed equation. So V equals distance divided by time. In this, we need to also know that it equals the change in distance over the change in time. We can also calculate this if we know the ending distance, and we can subtract the starting distance from it. If we know the ending time, we can subtract the starting time from it. Okay. Again, this triangle thing, it just means change. So how far has our distance changed? And how much has our time changed? So we're looking at a distance time graph. A line that looks like this would mean that the object is at rest or not moving. So a real life example of this would be if I'm sitting in my if a line is going down, but it's straight, first of all it's straight, we know it's constant speed. And if it's going down, that means the distance from the start is decreasing, and so it's going back to start. I'm going to let you figure out a real life example of that. Again, straight line, constant speed, and this is going away from start. And I'll let you figure out a real life example of this. And if it's curved up like this, at the beginning, it doesn't change very much. Excuse my pop-up there. Its distance doesn't change very much in the same amount of time as later on. And later on, it changes, there's a huge change in distance over a little bit of time. So what's happening there is it's speeding up. And the opposite would be slowing down. So take a moment right now and write some, pause the video and write some examples of when that would be. And I will check those. So let's look here then. What's happening? If this is a park, we've got time is on our x-axis and displacement or distance. If you want, you can write distance here, is on the y-axis. So we've got time is in seconds and displacement or distance is in meters. So during this time, in the first 2 seconds it goes 40 meters, and in the next 1 second it goes 80. So it's speeding up. So from time 0 to 3, it's speeding up. From 3 to 5, the distance, its displacement doesn't change. That means it's not moving or at rest. Either way is fine to say that. From time 5 to 7, that would be an example of the graph going down at a constant speed. So it is returning at a constant speed. Sorry, my lines are too short. If you wrote going back to start at a constant speed, that's fine as well. Now from 7 to 9, it is going away from 0, right? It's going away from 0. Remember, negative means a certain distance or a certain direction, excuse me. So it's going away at a constant speed. And from 9 to 12, it is with a constant speed. It goes 20 meters every second. And it is moving back to start. Going back to start at a constant speed. If at any point you don't know this word constant, means not changing. All right, now this is where we run into trouble. So how fast, that's going to be speed, was the cart going between 5 and 7 seconds? So we need to see where was the cart at 5 seconds and where was the cart at 7 seconds. So what we're going to do to calculate the speed is figure out how the change in distance during those 2 seconds divided by the change in time. So how far did that person go in those 2 seconds? Well, they started at 120 meters and they ended at 0 meters. So that means they went 120 meters. And from 5 to 7 seconds, that's 2 seconds. So now I just need to do some simple math, dividing 120 by 2, which gives you 60 meters per second. All right? If you need more problems like this, please come and see me. I can help you out figuring that out. You can also try calculating the speed between 0 and 2, and 7 and 9, and 9 and 12, and see if you can do that. If you need more help, let me know. Which person, now we're going to look at this graph down here. Which person, the one represented by the dotted or solid line, is going faster? So time is increasing here. So this is like clock keeps ticking by. And we're going to notice they're ending at the same distance. So if I'm going faster, that means that I get there in a shorter amount of time. So if we look at who, even though there's no numbers, we can assume that this time is smaller than this time. So the dotted line person is going faster. How do we know? Because it takes them less time to go the same distance. All right. Children of God, I hope that is helpful to you. I want you to try part 2 on your own, and make sure you study this before you take the retest. Please bring this to me. I will check this, and I hope this was helpful.